lesson 5, we're going to be focusing on polynomials, but one thing that's specific to this lesson is all the coefficients and the leading coefficient will be 1. Whereas in lesson 6, the leading coefficients will be numbers other than 1. So to get us warmed up, we're just going to go back to math 20. We're going to review a parabola. Okay, x squared minus x minus 6, when factored, gives us x plus 2 times x minus 3. It's basically telling us what our roots, our zeros, and our x-intercepts are. So if you look at the graph, where are your x-intercepts? What's this? 3 and -2. Okay, when we factor the function x squared minus x minus 6, we get our factors x plus 2, x minus 3. The zeros from each factor will be -2 and +3. And another term for our x-intercepts or zeros is roots, also as -2 and +3. So in summary, filling in the blanks basically, x-intercepts, roots, zeros, they're all the same. They're just satisfying the equation so that y equals 0. The biggest thing is it's where the graph crosses the x-axis where the equation equals 0. Okay? So you're trying to figure out values of x to satisfy the equation so it equals 0. So this lesson is basically looking at how to factor polynomials. And this first part here is going to help us develop skills to figure out which will be our first factor, which will be our first zero from the polynomial. So we're going to start basic just with a parabola. You guys probably could have figured out how to factor this. X plus 8 times x minus 3 gives us this quadratic equation. So if we had to state the zeros from these factors, what are they? -8, +3. Now what I want you guys to do is take a look at the constant, -24. Compare that to the zeros that you just told me. And can you relate anything? Is there any connection between -24 and -8 and 3? Good. Okay, -8 times 3 equals -24. So we're seeing that multiplying the zeros gives our constant from the polynomial. Let's see if that works for another one. We have a polynomial degree 3. When factored, we get x minus 2, x minus 1, x plus 1. The zeros from that would be 2, 1, -1. So if we multiply those, 2 times 1 times -1, do we get the constant? No. Pretty close, but not exact. One thing that's important to note is the sign doesn't matter. What we're seeing is that all of these zeros that we're finding are actually factors of the constant. Okay, all of the zeros are factors of the constant. And that's going to help us break down polynomials. So the integral zero theorem basically states that the zeros of an integral polynomial function with a leading coefficient of 1 must be factors of the constant term. Okay, so for example, if we had x cubed minus 7x minus 6, we would take a look at our constant and we would develop a list of possible factors. So numbers that multiply to 6. So 1 times 6, -1 times -6, 2 times 3, -2 times -3. All of these are possible zeros. Okay, so you list all the factors of the constant. Those are giving you potential lists of the zeros. So given this, let's just list again those potential zeros. Well, you don't have to list it again, it's already there. Okay, and we're going to, from those zeros, state some of the potential factors, which are binomials. so let's say we had a 0 of x equals 1. What would be your binomial? X minus 1. And if x equaled negative 1, we'd have x plus 1. So let's say we had x equals positive or negative 2. We would have binomials x minus 2 and x plus 2. Okay, for x equals plus or minus 3, we would have binomial x minus 3 or x plus 3. Lastly, if our potential 0 is positive or negative 6, our potential factors would be x minus 6 or x plus 6. Now tell me, would we use all of these factors? No, because if I multiplied x minus 1 times x minus 2 times x minus 3 times x minus 6 times the rest of them, I have 8 factors here. So x times itself 8 times gives me x to the power of 8. I only need x to the power of 3, which means how many of these factors will I actually use? 3 out of 8. So we just have to narrow down which factors they are. And the first step is pretty much a guess. Okay, we've listed all the potential factors. Now we're just going to try one of them. And the two that I recommend trying first are x minus 1 or x plus 1. Now Luke and Nicole, they decided they would give this a try. They wanted to factor the polynomial down and figure out which of those 8 factors were actual factors. We only need 3. So let's start with what Luke did. He first looked at the list of potential factors and he chose x minus 1 as a factor. He's just trying it. Then he used, what do we call, what's this theorem? Factor theorem or remainder theorem. If it equals 0, we're using the factor theorem. Okay, so he subbed in the value of 1 into the polynomial, and when he evaluated, dang, it didn't work. Okay, so x minus 1 is not a factor. So then he tried x plus 1, which means he's subbing negative 1 into the polynomial. So again, he tried the factor theorem. And this time he figured out, yes, I have my remainder of 0. So that means that x plus 1 is a factor. Okay, so if you get a remainder of 0, the binomial is a factor. Once we have established our first factor, we can use that on the side of synthetic division. Break it down, get a remainder of 0, and what does this tell us? The leftovers here, it's our quotient. So let's just establish what Luke has done so far. He started with a polynomial. He divided by x plus 1, figured out it was a factor, so this is our divisor. P equals dq plus r. Okay, this is our first factor, which was our divisor, and he resulted in a quotient that was x squared minus x minus 6, remainder 0. To fully factor this polynomial, what can he do with this trinomial? Yeah, we can factor further. So we get x plus 1 times x minus 3 times x plus 2. And there's our 3 factors. So what could we say the zeros of this polynomial is? Where does it cross the x-axis? -1, 3, -2. So Luke decided to use the factor theorem to start his work. If we take a look at Nicole's work, she decided that she would just use synthetic division right away. So just like Luke, she guessed maybe I'll try x minus 1. So she tried x minus 1. She ended up with a remainder of negative 12, so that didn't work. Okay, and since that didn't work, she decided, okay, I'm going to try x plus 1. So she took a second stab at it, just like Luke, and she realized I did get a remainder and I have my quotient that I need. So it's up to you, like if you make good guesses, you could get to this step right away. But if you make bad guesses, then you just have to keep going until you get a remainder of 0, and then you can apply synthetic division. So it's your choice whether you want to do synthetic division to get to that stage, or if you want to use the factor theorem. For me, I would probably choose the factor theorem because I can just plug this in quickly into my calculator and see if it equals 0. Whereas here you kind of have to write up the whole thing. So it's up to you. Let's try and factor this next one. So we have a polynomial degree 4. And let's just start by listing the potential zeros. So where do we get those from? Good. We look at our constant, and factors of 12 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. So combinations of those numbers we can multiply together to get 12. Chris, do you have to vote now? Okay. So we have to see which of these factors will work. So I would recommend starting with 1 or negative 1. We'll get some input from you guys. What do you want to start with first? 1? Sure. Okay, let's try P of 1. And when you solve that, what do you get? Zero, perfect. I was lucky. Okay, which means we can go right into synthetic division. So I'm just going to kind of make a little summary here. We can say that x minus 1 is a factor. And once we figured out that it's a factor, we can move into synthetic division.
Like you have to check it in synthetic division?
I don't have to check it, but the reason why I want to use synthetic division is to just break down the polynomials so I get my quotient, and then I can break that down further.
Oh, okay.
Okay, so step 1, we got to figure out what's a factor. Okay, we made a lucky guess. We chose P of 1, and it worked out. But maybe you chose P of negative 1, or P of 3, or P of 4. You have to keep playing around, subbing in values into the polynomial until you get a remainder of 0. When you get a remainder of 0, yay, you can move on. Okay, so we got P of 1 equals 0, so I can put 1 on the side of my synthetic division. Let's put the coefficients of the polynomial up top. So we got 1, 2, negative 7, negative 8, positive 12. Let's run through it. So bring down the 1. 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. Negative 7 plus 3 is negative 4. Times 1 is negative 4. Negative 8 minus 4 is negative 12. Negative 12 times 1 is negative 12. Plus positive 12, 0. And if you go to synthetic division and you didn't get a 0 at the end, but you got a 0 here, you did something wrong. Whether it was in this calculation or these ones, make sure that both have remainders of 0. So this here is my quotient. Okay, and if I write this out, I have x cubed plus 3x squared minus 4x minus 12. Now, Janae from the other class, she pointed out that, yeah, you could factor this by grouping. However, it's not going to be possible all the time. So rather than show you factor by grouping, I'm just going to show you how you would progress a question like this if you couldn't, okay? So we have one factor, x minus 1, but our other factor is still a degree 3 polynomial. So we have to, it's as if this is a new question. We have to start all over again. We need to find a factor that would break this down. Okay, so step 1, play around, figure out a factor that gives you a remainder of 0. Then use synthetic division to break it down. Step 3, we get to try again. But we're going to use this polynomial now. So, any guesses? What number do we want to pick from our list of potential factors? 2. Okay. So we're going to try P of 2. See what we get. I hope we're lucky. So replace x with 2. And what do we get? Zero? So we have 16 plus 16.
Wait, why do you do it with the original one instead of the quotient that you got?
Sorry, that's what you're supposed to do. But technically, if you subbed in there, you should get 0 too. My apologies. You should have said it earlier. I don't know why I looked back up here. Yes, you want to go from the quotient that you have. My apologies. Okay, so sub into the quotient we ended up with, and we get 2 at 3 plus 3 times 2 squared minus 4 at 2 minus 12. Do we get 0?
Yeah.
Okay, good. So awesome. That means that x minus 2 is a factor as well. And just to answer Emily, if you did sub this into the original polynomial, technically it's still a factor, so it would have worked out to be 0 anyway.
You just wouldn't have been able to bring it down yet?
You would have. This is just showing that it's a factor or not.
Okay.
So if it equals 0, regardless of whether you subbed it in here or here, we can go to the next step, which is synthetic division. So step 4, again, we're using synthetic division, but now the number on the side will be 2. Okay, and this is where it's important. We have to use the polynomial that we need to break down further. Okay, so we have 1x cubed, 3x squared, negative 4x, and negative 12 is our constant. So let's bring down the 1. 1 times 2 is 2. 3 plus 2 is 5. 5 times 2 is 10. 10 minus 4 is 6. 6 times 2 is 12. Negative 12 plus 12 is 0. And we have a quotient again. So step 5, maybe let's just write out what we have so far. Divisor times our quotient. Okay, we figured out our first factor was x minus 1. Okay, and then we ended up with a quotient of this, but we broke it down further and realized that x minus 2 was also a factor. And our last step of synthetic division, we resulted with a quotient that was x squared plus 5x plus 6. Let's put that in there. If I want to fully factor this, let's just take a look at x squared plus 5x plus 6. Can we factor it?
Junior class change.
We get x minus 1, x minus 2, x plus 2, and x minus, plus 3, sorry. So from the list of our factors, we need to state our zeros, and in other words, our roots. Okay, so from the first factor, x is 1, 2, so we have positive negative 2, and negative 3. Okay, those are our roots and our zeros. So in some cases, when you get to this step here, x squared plus 5x plus 6, you might not be able to factor. And do you guys remember from grade 11 when you can't factor what you'd have to do to get your zeros? Quadratic formula, yeah. So this next question, I'm going to teach you guys a little cheat, and I'm also going to teach you the algebraic way of how to calculate your exact zeros when you can't factor. So first, let's do the cheat. What you're going to do is put the polynomial into your y equals. Try that again. Okay, so you guys should practice this. X to the power of 3 minus 3x squared minus 3x plus 1. And let's just take a look at the graph to start. So that's what a third degree polynomial looks like. Now, we have degree 3. How many zeros do you see? 3 x-intercepts, yeah. So with third degree polynomials, you have up to 3 x-intercepts. How am I going to trace x-intercepts? Well, it's the same as how we did with a parabola. So you go second trace, number 2 for your 0, and you need to go to the appropriate left bound and right bound, and then guess. So my first 0 was negative 1. And I'm going to let you guys solve for the next one and the next one to the nearest hundredth. .27. Hannah, do you have a calculator? Give it a go. Speaking of which, did anyone lose a calculator? Or leave theirs here? No, okay. I have an extra and I don't know where it came from. Hey, when you solve for the last 0, what do you get? Nearest hundredth. What is it? 3.73? Yeah, okay, good. I guess technically to the nearest hundredth we have 0.002. Okay, so those are my zeros. Now, if I were to do this algebraically, I would have to use the factor theorem. I'd have to guess at a potential factor. So let's look at possible factors of 1. 1 and negative 1. Well, we kind of already cheated. We know it's negative 1. So do you think I'm going to guess 1 and try that? No. So this is kind of the cheat to get you started for algebraic solving, or factoring polynomials. If you're stuck, you can put the polynomial into your calculator and just figure out one of the zeros that's an exact 0. So none of these decimals, but like negative 1, that would be like a very precise 0. So there's no decimals that you need to worry about. So you could then take that value and just test it if you want. This is how we would actually do it algebraically. You'd sub in p of negative 1 into the polynomial. And we're going to prove that p of negative 1 or x plus 1 is a factor. Now, if we found our first factor, we can then go into synthetic division. So in the last example I said try a value. This time I'm telling you, although it's good to know the potential factors, because that's types of questions you might see on your diploma, if you are lost or maybe forget, you can always graph a polynomial and find the x-intercepts graphically. Okay. So once we found our first factor, we can go into synthetic division. Negative 1 on the side, coefficients of the polynomial up top. 1, negative 3, and 1. And we're just going to go through the process, figure out what our quotient is. And after all that, we do get a remainder of 0, which is good. And we figured out our quotient is x squared minus 4x plus 1. Can you guys factor that? Can you find two numbers that multiply to 1 and add to negative 4? No. So we have our polynomial is equal to our divisor, which was x plus 1, times x squared minus 4x plus 1. In this case, we cannot factor. Therefore, use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b is negative 4 plus or minus the square root of negative 4 squared minus 4 times our a times our c, all divided by 2 times a. Just cleaning things up, we get 4 plus or minus the square root of 16 minus 4 is 12 over 2. Hi Mitchell, do you need your test? Okay. So do you guys remember how to break down a radical? Square root of 12? Let's do that up here quick. Square root of 12. 12 can be broken down into 4 times 3. The square root of 4 times the square root of 3. What's the square root of 4? 3 root of 3. Is there a common factor of 2 in all the terms? Yes. So we can simplify further. 4 divided by 2 is 2, 2 divided by 2 is 1, and we get x equals 2 plus or minus the square root of 3. So that's from this trinomial. What was the other root from this one? Negative 1. So our actual final answer needs to be 2 plus or minus the square root of 3 and negative 1. Okay, those are the zeros. And that's how you would answer them in exact values. So if you have a question like this, and I say you need to find your exact values of your zeros, you can't just go to your calculator and find these decimals, because good luck if you can guess that it's 2 plus or minus square root 3. Okay?